Since we have discovered many ways of solving for x, such as by factorization or by using the quadratic formula, in this lesson we'll be focusing on how to complete the square. So we want to determine the roots or the solutions to an equation by completing the square. Now the first example which we'll look at, let's say x squared plus 5x plus 6 is equal to 0. So here are the steps for how to complete the square. So the first step is to make sure that the coefficient of x squared is always 1. If it is not 1, then divide by the number that it is here. So that is here. So that you can get 1 as the coefficient of x squared. Step number 2 is to isolate the constant. So that's the second step on how to complete the square. The third step will be to add both sides, half times the coefficient of x squared to both sides. So we're going to add this term to both sides. And lastly, you just simplify. So I'll take you over these steps so that you can know how to follow them. So the equation that we have here is x squared plus 5x plus 6 is equal to 0. Because here we have a 1 in front of x squared, our first step is complete. We don't have to divide by anything. If it was 2 here, then we'll have to divide all the terms by 2. But since it is 1, we don't have to divide by 1. 1 divided by 1 will just be 1. There's a 5 here. The second step will be to isolate the constant. Here our constant is 6. So I will take the 6 to the right hand side and it becomes negative 6. So x squared plus 5x is equal to negative 6. Now, the third step is to add half the coefficient of x to both sides. So the first step to do here is to ask yourself, what is the coefficient of x? In this case, it's 5, right? The number that stands before x is what we call a coefficient. So meaning I have to add half times 5 to both sides, right? So you have to add half times 5 to both sides. So let's see. I'm going to have x squared plus 5x plus a half times 5 squared is equal to negative 6 plus a half times 5 squared. So the reason why we add to both sides is so that we don't change the net expression. Remember, whatever you do on the right, you must also do on the left. Now let's simplify. X squared plus 5x plus 5 over 2 is going to be 5 over 2 squared. And this will be equal to, let's simplify the right hand side to see what we get. So it's half multiplied by 5 all squared, which is 1 over 4. So the next step here will be to take x and the 5 over 2, the number which is inside here. Okay, so I'm going to take x and the number inside the bracket here, which is 5, positive 5 over 2. I square it, then I equate to my right hand side. So I'm trying to solve for x here. So I'll introduce square root both sides. Whenever you introduce square root to a constant, you put plus or minus. So if you square root a number squared, it becomes that number. So the squared goes. So this will be equal to plus or minus. What is the square root of 1 over 4? It's 1 over 2. Now this means that x plus 5 over 2 is equal to half, or x plus 5 over 2 is equal to negative half. Remember we said positive half or negative half. That's why we're putting two different signs because of this plus or minus. I just expanded. So if we solve for the first value of x, x1 will be equal to a half minus 5 over 2. x2 will be equal to negative a half minus 5 over 2. So you know the rule that says if you have the same denominator, you can add the numerators. So I'm going to apply that rule here. If we simplify, your answer will be negative 4 over 2, which is negative 2. This side, the same thing, the same denominator, you add the numerator. You're going to have negative 6 over 2, which is negative 3. So these are your two values of x which we have solved by completing the square. So this is how you can complete the square. Just have to follow the steps and everything will go well. Okay. So this is how you can use completing the square to solve equations. Let's have a second example. Suppose we have got 2x squared minus 2x plus let's put it minus 24 is equal to 0. Now solve for x by completing the square. Now let's see, our first step is to make sure that the number in front of x squared is 1. Since it's 2, I'll divide everything by 2. Then I will have x squared minus x minus 12 is equal to 0. My first step complete. My second step will be to isolate the constant, meaning I'll have to take a negative 12 to the other side. It becomes positive 12. Second step complete. The third step will be to identify what is the coefficient of x. The number that stands before x is a negative in this case, meaning it's negative 1. So I'm going to add half times negative 1 squared to both sides. So I'll add this term to both sides. Then I will have x squared minus x plus a half times negative 1 squared equal to negative 1, equal to 12 plus a half times negative 1 squared. If I simplify, I will have x squared minus x plus any number times negative 1, the negative version of that number. Then let's see what we get on the right hand side. So 12 plus a half multiplied by negative 1 squared is 49 over 4. So let's see. I'm going to take the x and the number inside the square root, which will become x minus a half. If you don't understand why we do this, we don't have to worry a lot about that. But if we want to find out, we're just expanding. If we know how to expand a polynomial, here we're just contracting it. Okay, so how can we solve for x here? I have to introduce square root both sides. But remember, whenever we square a number or a constant, you must put plus or minus. So x minus a half is equal to square root of 49 over 4 will be 7 over 2. In this case, plus or minus 7 over 2. Now, if we solve for x, this means that x minus a half is equal to 7 over 2, or x minus a half is equal to negative 7 over 2. You can take the half to the other side. Your first value of x here should be positive 4, or your second value of x should be negative 3. Okay, so this is how you can use completing the square to solve equations. So now let's say you are not given numbers, so just given variables, right? How will you do it? So let's see how we can do this. I'm just gonna clear some space here. So let's say you are given something like p x squared plus q x plus t is equal to 0. Now how can we complete the square here? We're gonna apply the same logic, right? So here our independent variable will be x. So p, q, and t are constants, right? These are real numbers. So what is the first step of completing the square? Is to make sure that the number in front of x squared is 1. But in this case, we have p. So I'll divide all these terms by p. Okay? Then I'll have x squared plus q over p times x plus t over p. Then I'm going to isolate the constant. meaning I will shift this constant to the other side, and it must change a sign, right? So I'm going to have x squared plus q over p. X is equal to negative 3 over p. Now, the next step is to identify the coefficient of x. So in this case, the coefficient of x is q over p, meaning I'll have to add half times q over p squared to both sides. Then I'm going to have x squared plus q over p times x plus a half multiplied by q over p squared is equal to negative 3 over p plus a half multiplied by q over p squared. Then let's simplify. X squared plus q over p, x plus q times 2p, this will become q over 2p squared is equal to negative 3 over p plus. Now if you do this, you must end up with q squared divided by 4p squared, right? Let me erase here. So what do we do here? We take x and the number in front inside this squared here, and we put them inside a bracket. So it's x plus q over 2p squared is equal to negative 3 over p plus q squared over 4p squared. Now, how can we make this term here to have the denominator 4p squared? I'll multiply the top and the bottom by 4p over 4p. Then I'll have x plus q over 2p squared is equal to negative 4pt over 4p squared plus q squared over 4p squared. Okay, then from here, let's just rearrange and write our expression more nicely. This will become q squared minus 4pt. Remember, we keep the denominator and add the numerators. Now let's square both sides and see what we get. I'm going to introduce square root both sides. On the right side, I'll just have x plus q over 2p equal to. Now, when you square this one, you just have to separate the square root. So I'm going to square root the top and the bottom separate. Okay. Now, the upper part, we don't know what exactly that term is. So we're just going to keep the square root. Remember, this thing must say plus or minus, right? So this is plus or minus here. The square root of q squared minus 4pt divided by, if I square root 4p squared, all these numbers inside the square root are perfect squares. So I'll have 2p, right? So let me erase this. Okay, so now we end up with this expression. X plus q over 2p is equal to plus or minus the square root of q squared minus 4pt over 2p. Okay, so now let's see what we can do here. X is equal to negative q over 2p plus the square root of q squared minus 4pt over 2p, or let me shift this a bit this side, or x equal to negative q over 2p minus the square root of q squared minus 4pt over 2p. Remember, we said plus or minus. That's why I'm just splitting this plus or minus into two separate terms. Now, if I can just join these things, if we check this term here, it has the same denominator of 2p. Then I can keep the denominator, which is 2p, and add negative q plus the square root of q squared minus 4pt, or x equal to the same thing here is 2p Then I've got negative q minus the square root of q squared minus 4pt. Now, if you can check these two terms here, this first solution, the second solution, they are the same, but they just differ by this plus and minus. Meaning we can join this and make it, we can contract it such that x1, 2 is equal to negative q plus or minus the square root of q squared minus 4pt divided by a 2p. Then this is your solution. So you just have to treat this thing as if like you're treating numbers. So if it doesn't make sense, make sure to watch the video as many times as you can. So this thing is what we know as the quadratic formula. So where it comes from completing the square. So this is what we just did here. We just proved the quadratic formula by completing the square. But if you're given such an expression like this one, you don't have to go all through this. You can just simply plug the values into this expression and you will get the roots. Thank you for watching.